Science involving variables, okay? So let's start off here. That's what I call this section, right? So first thing you should notice, right, is that these lines are parallel, which makes in this, I told you, right, that a parallel line can also be a transversal. Did I tell you that? It could be. But right now, if these are my parallel lines, I make this my transversal, okay? And then I noticed something. I tried to name these. Okay, what would these two angles? And they look weird, don't they? Right? Yeah, it's because there's an unknown in there. But I know that these two are uh, alternate, right? Alternate exterior, right? Angles given are alternate exterior angles. I know, right? They are congruent. Okay, very important to know what do I know about this pair. This pair in this case is equal to each other. Which one is not equal to each other? The CIAs, right? Those are not, but the other three are. So the other three are actually the easier case, right? So you take 7x plus 28. I put that in brackets because whatever we get out of this will be in degrees. Okay, so I write it without brackets when I make them equal to each other. I don't worry about it. So you notice that, right? This is a solving for x, a classic isolating for the variable. Okay, so isolate x, whatever variable is there. Isolate x, y, z, you name it. So I'm going to bring, I don't know, I always teach it like this, but I will say, hey, 7x is already on the left side of the equal sign. So the 2x comes over, subtracting, right? You're basically subtracting 2x from both sides. Equals. The 78 is already on the other side. The 28 here comes over, subtracting. So when you bring terms over the equal sign, the sign changes. Okay. And so this ends up, you end up with 5x, and this ends up with as 50. Perfect, it's not always round. It's not always a perfect round number. In this case, it is. Divide both sides by 5, and x is equal to 10. So this would be crucial to get you started. And am I justifying and showing work? Absolutely, right? You could have just started like this and just said alternate exterior angles are congruent. Like that would be an explanation as to why you're setting it up like this. This is self-explanatory. And now you figure out one of these angles because they're equal to each other. Okay, so we're going to say 2x, 2 times 10, so I'm using this one, 2 times 10 plus 78, that is equal to 98 degrees, correct? This, let's go arrow out. We went here, we plugged in x into it, right? And then we just added 78, we got 98 degrees. So this is very important. Because once you know that this is 98 degrees, you also know that this is 98 degrees because they are equal to each other. You can try it though, right? 7 times 10 is 70 plus 28 is 98. So regardless of which one of these two you pick, you get the same answer. Okay. Now that you have this, so I'm gonna highlight that. Right? Now that you have the 98, you can solve. It's almost like now it's back to what we were doing up until now. Right? So A is, angle A would be, what are these two? Vertically opposite, and we know they're the same, right? So you just go vertically opposite So I feel like you are on the right track. You're getting it. Okay. And B, let's allow me to do this. I'm going to go 98. It's probably a good idea to just. And what do we know about these two? How about we just follow this? We go over here, vertically opposite, right? How can I relate these two? Consecutive interior, and they add up to 180, right? Or you're like, no, I don't like CIA, right? What are these two here next to each other? They're along the straight line, so just straight line equals to 180. Regardless, you get the same answer. So I'm going to go, this is 180 minus 98, so that's 82 degrees. Okay, consecutive interior angles are equal to 180. So now you've answered, you've done a bunch of things. You've figured out what x is. You figured out x, now you use that to get you started, right? To get an angle. And then you solve for a and b, right? So quite a bit of work. And so I don't want you to think this, oh, this is how it's always going to be. That's not what I'm saying here. Can I ask you to always think of what are you doing to start you off? What do you know about the angles in question? Do they add up to 180? Are they equal to each other? And so forth, right? So let's try another one to shake things up here. I'm going to leave it like that for a bit. Okay. How could I start here? I'm going to think out loud here. I see parallel lines. What else do I see? A triangle. Do we see a triangle? Because what I want your brain to do is like, okay, there are three axes there. So I will first and foremost focus on these, and I will tell you why. I don't want you to just take it and go with what I'm saying here. Are these two angles, this one up here and this one, do I have a name for them? You might be tempted to say consecutive interior. I don't know. I like ignore this line for a bit, right? But there's no parallel line up here, right? That is attached to this one. So you can't do corresponding, you can't do any of that. So you're stuck, right? Same here, you couldn't say that. There's nothing to connect these two because this line and that line is definitely not parallel. So you can't even call this, right? You can't connect those two like that. So you must use a triangle in this case. So what I will do is I will say that the sum of triangle is equal to 180 degrees. That's my starting point. I'm telling myself what it is that I'm going to do. So I'm going to say that angle 2x, right? Let's put that in brackets, plus that other angle here, x minus 12, plus the 5x, right? If I were to add up those three expressions, I should end up with 180 degrees. It doesn't matter what they look like. We know that this is true. And then you just clean it up a bit. You don't really need brackets, right? You can just say this is 2x plus x, right? Plus 1, there's a 1 up front here, correct? Plus 1 times negative 12 is just negative 12. So you're basically foiling out any expressions that are there. And the ones that just have the 5x or the 2x, there's no need to have brackets in the first place, right? I'm just showing you that we're basically inserting our three angles there. So then here, 2x and 5x, that would give you 7. Sorry, I'm missing one x, right? There you go. 2x and that'd be 3x, 8x, right? 8x is equal to, on the other side I have 180 is just by itself, the negative 12, that's the only constant, right? I'm bringing that over, adding. You got to be very careful that you get your signs right. So then 8x is equal to 192. Everything is in degrees here. Divide both sides by 8. And that is 24, right? Just gonna check. Yeah, that is 24. Don't want to get it wrong in your notes. 24 degrees, that is. So you just found, by the way, up here, when you found the 10, that was also in degrees, right? We're solving for angles. So 24 degrees. And now you could solve for A, B, C, and so forth. But this is what you want to do first. Pick one of these and just plug X into them. Okay. So I'm going to go, I'm going to do this. 2x, sorry, 2x is 2 times 24. That's 48 degrees. That is this one here. Okay. Are they all the same? Are these all the same? No. So you need to actually plug in every single one. And I'm going to eat into this one, and I don't want to do that. But then I'm going to go 24 minus 12 is 12 degrees. And then I'm going to call this 5x, right? So 5 times 24. That's 20 and 10, so 120. I could have just found that by okay. So once you have x, in this case, you have to plug them in into every single one to get you started. And I did not leave you enough room on this one. I apologize. It's kind of messy. I'm just going to box this in, okay? This is kind of where I'm just finalizing. There's not a whole lot happening other than just plugging in. Maybe on a test or quiz, AC, what have you, you can just go arrow out like this and just do the math there. Okay, I should have done that. And now let's find A, B, C, and D. So let's see how room is going to be the problem. But I'm going to go angle A here. Angle A will be, I'm going to go straight line here. Straight line. So I'm going to go 180 minus 48. Okay. So that'd be 132. And I will say that it's straight angles equal to 180 degrees. I hope you can see that. It's a bit small, sorry. Angle B, whereas B here, I'm going to use vertically opposite there. So 5x is 120. So vertically opposite angles are congruent. Why don't we write in those angles that we already know? I think that'd be better to do it that way, to not mix things up here. Okay. So we know those, we found what they were. And then C, let's use something we haven't used so far. If I know that B is 120, can I relate these two here? They are corresponding, right? So I know that this is 120, and I just say corresponding angles are also congruent. So now I know that this is 120, right? Hey, look, alternate interior are also congruent. So that's kind of checking out, right? It should be that way, right? These two are alternate interior. They are congruent, right? D, I will do corresponding here. So because A is already 132, I know this one. Corresponding. They're not alternate. So angle D, go ahead. So this is 132 corresponding. Let me zoom in if you're squinting right now and you're like, I can't see. There it is. I hope that's better. Let me just focus it once. There you go. So write that down. So I want you to, I'm wondering if I should give you this as homework. I think some of you might need an example on this. Let's pause this for, I'm going to skip to the other one because I want to do that one because now you have an idea. So let me just tell you a little bit about this one. Let me tell you the story behind this one. Right now, there's no story. Right now, those two, do we have a name for them? One of the four? Not corresponding. They kind of look corresponding, but they're not. Because one is, they're both on the outside. We don't have that. Alternate exterior, we don't have that. Corresponding exterior, I like the creativity there. Yeah. But we don't have that, right? We don't have a name. So we need to massage this one. We need to make something happen, right? Can I try to get this one here? This one perhaps, knowing that I know this one. You might think, it's going to be ugly. Well, let me show you what ugly looks like, okay? This angle, or, I have a better idea, but that might make it a little bit, I will just go with my thought here for now, okay? This angle right here would be what? What are these two? They add up to 180, right? Would you agree? So to get this one, I would have to go 180 minus 3x plus 4. Would that make sense if I told you that? If this is 3x plus 4, then this angle right here is 180 minus whatever is here. Right? So do we have a name for these two now? Yep, they're corresponding. So I'm going to highlight that, highlight that. I think we'll have enough time to do this one and the backside. So this is the hardest one of them all, like this scenario, because you have to do a bit more than just going with it. You know what? My temptation is to just leave this up to you now, and then I'll come back to it tomorrow. So I'll put homework here, homework as well, right? AC question 3, right? So if you want more practice on this particular type, was there some in the homework? I think there was some in the homework that I assigned after Friday. There were some of these there. So if you were stuck, now you know, right? Now you know how to do it. I have a feeling it was on there. So this is the most challenging, but I think you got it from here. You just have to apply algebra, be careful with your signs, all of that fun stuff, okay? So to be continued, right? Let's go to the real tough cookie here. I'll never, you will never have this many on an AC on a particular graph, but It could be a combination of these, okay? So you want to be prepared for that. Before I start, we've got under 10. I want you to think a little bit about it. So I'll give you 2 minutes to think